Let's continue the application. I still have part 6, 7, 8, 9, and part 6F. So I'm solving the trigonometric equations. So I have here 2 cosine squared x minus 3 cosine theta, sorry, equal to minus 1. So if I take minus 1 to the first part, I can see that it will remind me about the quadratic equation as I'm saying that I have 2x squared minus 3x plus 1 is equal to 0. So I can do it on the calculator. I can do delta, or also it's a plus b plus c. So the first solution is 1 and the second one is half. But it's not theta is equal to 1 or x is equal to 1. It's cosine theta is 1 or cosine theta is equal to half. Cosine theta is 1. We know that when I say cosine theta is 1, it means it's here. It's on this part. So I can either say the angle is 0 or 2 pi. Now cosine theta is half. It's positive. It means I'm working either in quadrant 1 or in quadrant 4. If I take my calculator and I do shift cosine half, the calculator will give me pi over 3, or it gives me 60 degrees. It means the angle in quadrant 1 that gives me cosine half is pi over 3. But also the angle in quadrant 4, it gives me the same cosine. And how are we going to find it? Either I do minus alpha, or it means minus pi over 3, or I can do 2 pi minus alpha, or 2 pi minus pi over 3. And if I do the same denominator, it gives me 5 pi over 3. Now we move to part 7. I have 4 sine squared theta is equal to 1. I'm solving for sine, so sine squared theta is equal to 1 over 4. So sine theta is equal plus or minus radical 1 over 4. So sine theta is equal half or minus half. Sine theta is half. It means sine positive quadrant 1 or quadrant 2. Now, if I take my calculator, I know that the angle pi over 6, it means 30 degrees, gives me the sine half. So which other angle also gonna give me the same sign? It's the angle that is in quadrant 2. How do we find this angle? What is the relation between angle in quadrant 1 and quadrant 2? It's alpha and it's pi minus alpha. So the first angle is pi over 6 and the second one is pi minus pi over 6. So it gives me 5 pi over 6. Now, sine theta is equal minus half, sine is negative. In which quadrant sine is negative? We know that it's in quadrant 3 and in quadrant 4. Excellent. Which angle gives me sine half? It's pi over 6. How do you find the angle that is in quadrant 3 and that it has a relation with the angle in quadrant 1? It's pi plus alpha. So if I am here, this is alpha, which angle has the same sign but it's negative and then it's in quadrant 3? It's this one here opposite to it, so it's pi plus alpha, so it's pi plus pi over 6, so it's 7 pi over 6. And also we said it's in quadrant 4, also it has a negative sign here in quadrant 4. So this one, either I can say it's minus alpha or 2 pi minus alpha. So either I can say it's minus pi over 6, or also I can say it's 11 pi over 6. Now we move to part 8. Now here it's 8 and 9 are different. I'm not solving sine theta is equal. I have sine 3 theta over 2 is equal. So this is the big theta that I have. I need to think exactly the same. Sine is negative. It means I'm in quadrant 3 or quadrant 4. It means it's pi plus alpha or minus alpha or 2 pi minus alpha. I take my calculator and I do shift sine 0.62. It gives me alpha 38 degrees. But I don't write theta is equal 38 or pi plus 38. What is the angle here that I'm looking for? It's 3 theta over 2. So it means 3 theta over 2 is equal pi plus alpha. So this is pi plus alpha or minus alpha, or I can write also 2 pi minus alpha. And then I solve for it. So I do 180 plus 38, and then I cross multiply. So and theta gonna be 180 plus 38 times 2 over 3, and then the first angle is 145.3. Exactly the same I saw for the second one. 3 theta is equal minus 38 times 2, then theta is equal minus 38 times 2 over 3, and then I will have the second angle theta. So it's here, either I can write big theta or I can write big alpha or a gamma, any angle. Now I move to the last one, also exactly the same, tangent 2 theta. So when I'm solving here, I will write 2 theta is equal. So tangent is negative, it means I'm in quadrant 2 or in quadrant 4. I take my calculator. If I do shift tangent 0.4555 without the minus, gives me that the angle is 24.4. This one is in quadrant 1. What is the angle that has the same sine, the same tangent, but it's opposite? In which quadrant it should be? It should be in quadrant 2. If if I'm in quadrant 1, how I move to quadrant 2? I will do pi minus alpha. So 2 theta is equal pi minus 24.4, or 2 theta is equal minus alpha, or 2 pi minus alpha. So I will have 2 theta is equal 180 minus 24.4. Then I solve for theta. So theta is equal 180 minus 24.4 over 2 and gives me 77.8. Or theta, 2 theta is equal minus alpha. So minus 24.4, and theta will be minus 24.4 over 2. So it's minus 12.2. So every time you are solving any equation, let's do a small summary. Any equation, sine or cosine or tangent, you look at the answer first. And then if it's positive, you precise, positive or negative, precise the quadrant. We know that sine is positive, it's in quadrant 1 and quadrant 2. So quadrant 1, it's alpha. Quadrant 2, it's pi minus alpha. Now, if it's negative, the sign, it means I'm working in quadrant 3, and I'm working in quadrant 4. Quadrant 3, it means pi plus alpha. No, it's not writing. And then quadrant 4, it's either I can use minus alpha or 2 pi minus alpha. The same. Cosine theta. If I'm positive, quadrant 1 and quadrant 4. Quadrant 1, it means alpha, and quadrant 4, it's minus alpha or 2 pi minus alpha. And if cosine is negative, I am in quadrant 2, or I'm in quadrant 3. Quadrant 2, it's pi minus alpha. Quadrant 3, it's pi plus alpha. And also for tangent, positive, it means I am in working in quadrant 1 and in quadrant 3. So it's alpha and pi plus alpha. And negative, I'm working in quadrant 2 and quadrant 4. It means it's pi minus alpha and minus alpha. So first you check the sign, you see if it's positive or negative, you precise the quadrant, then you take the value without the minus, you make it on the calculator, and then you either find it pi plus alpha, pi minus alpha, 2 pi plus, minus alpha, or minus alpha. That says we're done with the application. We'll see you later in another